So again, welcome you all to IGC and good afternoon, guys. So in this half an hour to 45 minutes, first we will discuss about support provided by IGC for GATE Aerospace and in online platform. Okay, on online platform. So we will limit our discussion about online coaching, though we have been providing earlier offline coaching in Bangalore and we were very good in that as well. So here this GATE Aerospace online coaching is for Pan India students. And first we will go through course details. So for GATE 2022 and 2023 Aerospace Engineering, we will take classes around 4 to 5 days in a week. It is not like some people have this confusion, we will have only weekdays class. Some people will have this confusion, there will be only weekends classes. No, so classes will be combined 4 to 5 days in a week. Weekdays classes we will be taking twice to thrice, like Tuesday to Thursday or Tuesday and Thursday. Timing it is in night, 9 p.m. to 11:30 p.m. max. So all of you were available at that time, right? Because some people even working or college students, they are available in that time. We are not taking any classes in evening because evening is the worst time to take classes. Either students are busy or internet issues and all happen. So we know that Saturday class timing in last year when lockdown was there, it was 2 p.m. to 7 p.m. But we may vary this Saturday timing from 5:30 to 10:30 p.m. In between there is a gap. Okay, 1 hour dinner gap will be there, like 5:30 to 7:30, then gap, and then there will be class like 8:30 to 10:30. Sunday timing is already fixed. It is morning 9:30 a.m. to 2 p.m. So in between there is a gap. 9:30 to 11:30 one class, then 11:30 to 12 there is a break, and then 12 to 2 another class. So these are the timings. Now it comes to Monday and Friday. Usually Monday and Friday we do not take class, and you guys are joining in February batch, so hardly we take any class on Monday and Friday. Now the duration of the course is around 500 hours over the period of 8 to 9 months. All the classes are live interactive, and here we have already proved we have done it in done for GATE 2021, and we are going to do in a much better way for GATE 2022. And here we are not going to promise you 700 hours of classes or 800 hours and all, because that is not feasible. Okay, with this teaching arts and online classes should not be marathon. You guys know, right? You cannot sit 8 hours in front of your laptop or mobile. So we have given enough planning, and classes of each session will be of 2.5 hours. Okay, so this is about the course part. I'm going further now. We will teach 100%. Okay, we will teach you guys 100%. Nothing will be left out. And if you want to ask or if you want to check, you can always ask your friends, because we have taught students from almost every college. Even we have taught students from good college like Punjab Engineering College or IIEST Sipur, MIT Chennai, FGIT Raebareli, and many other private colleges. Okay, so you can ask the way we teach, how we teach, and do we cover everything or not. And again, everything will be completed within time frame. Okay, and within or at least 2 months prior to GATE exam. No delay in syllabus completion. Okay, mathematics and aptitude will be also taught. So classes are live interactive. What live interactive means, like offline class, you can ask any doubts through audio discussion. Okay, like in offline you ask doubts. Then another way you can ask your doubt through chat box. Okay, in any of our class, and we are not restricting anyone to speak, but when you speak, your surroundings should be, surroundings should be not very noisy. So that is one request we do to everyone. Now, after class recording will be also available. So if you miss any class in any day, you can go through, and this is the advantage of online class. In offline class, there was no concept of recording of class, but in online class, you can avail recording of class if in any case you miss any class or if you want to revisit class. So syllabus is anyway will be covered 100% for everything except English grammar we do not teach. Study material is provided in e-form to everyone, okay, whoever joining our classes. Topic-wise assignments are provided for self-practice. These topic-wise assignments will be a bit lengthy, and we also provide solution for assignments. For majority of the assignments, we provide solution because assignments may take time to solve. Okay, questions will be lengthy. Considering if you solve lengthy questions, then gate kind of questions will be very easy. Okay, and if you consider paper 2017 or 2020-21, students have struggled a lot. The reason they are selling questions were lengthy. So that means if your practice is there in prior solving lengthy questions, then gate exam will become easier. And that is like a USP of IGC coaching. In IGC, we will prepare you guys more than what is required in gate exam. Okay, that is what our way of working. Okay, you will be prepared even sometime well for your master's program. Okay, if you go there in master's, you will feel yes, IGC learning is helping a lot. Okay, now apart from topic wise exam, we have many online exams. So initially online exams will be topic wise exams, like whatever topic we cover there will be exam, okay, for SAM. And this topic wise online exam will run throughout year till November. So till November, whatever subject we teach, whatever topic we teach, there is an online exam. So that is for like students become sincere, they can judge how they are doing in exam, and that is the way of tracking for us also, and you guys can track for yourself how you are doing and how you are learning. Then in December month we have subject wise exams, and January is a 10 full length syllabus exam we take. So this year out of 10 full length we have given 2 full length exam outsider also, those who were not IGC student. But I am happy to say in all our both full length exams all the toppers were IGC students. So that is kind of satisfaction for us, because sometimes we want to check how others are doing in our work, because it's a standard work and on set parameter. And all those who are doing good in IGC exams, they will be topper this year. There is no doubt in that, because some of our students were unhappy even after attempting 64 questions. One of our best student was unhappy. The only reason was he couldn't attend one question, just one question he couldn't attend. Okay, so when in tough questions, if you can solve 60 questions or 64 questions, there is no doubt they will be ranker. Okay, and we are expecting we may get even 5 people in top 10, or at least 2 3 will be there. There is no doubt. Even in last 2 years also there were two students in top 10. This year this number will go up only. And uh, if you consider in top 100, of course we may go up to 30 people or more. Now this is about exam. Now come to doubt. You guys might have seen our some of the WhatsApp picture. We are very well known to provide very good doubt support, not just for our class students, even for our test series student, even for our DLP student. So if you throw any doubt, we'll try to resolve it and we'll address. And another good part in IGC, we never provide direct solution for test series. Okay, in test series we will support for doubts. We will not provide spoon feeding. Okay, that's where your problem solving skill will improve. When you have to put your all head to solve a single questions using references, using class notes, using the NPTEL or whatever, then only your learning will improve. Okay, your thinking will improve how to how to target new questions, because in gate exam, questions will not repeat, but rather concept will repeat. So our always idea, everyone must learn concepts well. Okay, so this is what about online exam. No, and doubt classes will be there. Of course, this year we will, during course itself, we will have some doubt classes every month or twice in a month. It was a suggestion from some of the students, and always at the end we have doubt and dedicated problem solving classes where we only solve questions and take up doubts. Now, in terms of the fee is 25K. It is even half of the fee taken by some institute, you guys will be knowing. Okay, and for 2 year program it is 40K, which is lesser than for 1 year people are taking. Okay, of course some concession we may provide based on the case to case, and those who claim concession, of course we ask credentials to them, like academic credentials or any other financial conditions. But some people earlier also claimed financial conditions, but they were not up to mark in terms of the putting hard work. So if we provide someone support, we expect hard work from those people. Okay, but our experience was not that good in that. Okay, so it's very simple now at IGC. Everyone has to pay. Okay, those who are taking classes, and of course, whatever we promise, we will deliver. Okay. Now, reading and books, all the e-books are provided either for engineering, mathematics, aptitude, or for all technical subjects. So this is about the course part. So any concern or any doubt in this, guys? Okay. Let me check. One doubt is there. What is written? Is there any flexibility in taking weekly online exams according to our yeah. There is lot of flexibility, but don't be so flexible that your all exams are due by November. Okay, exams are like that only in IGC. Exams are can be taken anytime, anywhere. Okay. Usually we open exams for a particular subjects when we start teaching. Like now we are going to start with mathematics and engineering mechanics. So we will start exams for both subjects by this month. And English, yes, we provide the references. We have assignments also, Shrey Anand. Okay, but we do not teach English because even I am from a Hindi medium background, and I know it it is all about individual background from where they have grown. Okay, the weekdays, and no, that's what I have explained, Mohammed Sadiq. The batch is single. There is no weekdays and weekends batch in online coaching. A single batch where we teach 4 to 5 days in a week, and everyone has to attend all the classes. If you miss any class, in any case, of course recording is there, but it depends, because in IGC recording is also quite good. Okay, so don't just over depend on recording always. Okay, it is better if you come to class, you will learn more. Okay, you can ask doubts as well. So just a moment, guys. One call. Yeah, so guys, now any other doubt or concern? So classes will be taken. No. Classes are not in Cisco. That part I will explain. Classes are taken on IGC online platform. Okay. There is separate platform for online coaching by IGC. Why we are taking this session in Cisco WebEx? Because here you guys could join directly. Okay, no credentials are required. Okay, just by link you guys can join. Same thing we are going to inbuilt in IGC platform also. We just share the link and anyone can join. Okay, but all those who have joined have registered, right? There should not be any unknown. Otherwise, I will remove from meeting. Okay. So I guess most of you, I can see either you guys have already registered or you guys have already paid fee. Okay. So this is what. Yeah. Any other concern on this course part, guys? No concern? Okay. So let's move to next. That is also very important. Now this is about team IGC details. So you can see here there are several faculties, right? Including myself. So I take care of aero structures, mechanical vibration, and space dynamics part. And about me, I am one of the most experienced faculty for GATE Aerospace in India, as I passed my GATE in 2009, and I have been guiding or mentoring GATE Aerospace students from 2010 itself. I have one of legacy, which I will share with you guys. One blog which I have written for GATE Aerospace Decoded, which was shared by some people in Quera for many years, and lot many good feedback or support is there for sale. Okay. Now another part about IGC, we are not like one man or two man army institute. We have dedicated faculty or subject expert for every subject. Okay, and they take care of their part. Now another advantage with IGC, either it is offline learning or online learning, we do not have much difference in terms of the deliverable. We are equally good like we were in offline. The reason behind a dedicated team, and here we start again from scratch. Even if it is online coaching, we are starting with mathematics and engineering mechanics only. Okay, so this is what we have not changed in the deliverable or planning the way we teach. So basic subjects also we have good teachers like Rishi sir take care of fluid mechanics and thermodynamics. Engineering mechanics will be taught by Anubhav sir. His name is not listed, but he is from mechanical team because engineering mechanics is common with gate mechanical. Now then you can see Hemraj sir is there. Nitin sir today he will be taking your demo session. So they have expertise in aerodynamics and flight mechanics. Then we have Navneet sir, he is expert in flight mechanics. Propulsion we have Jasraj sir, we have Pratik sir. Now Pratik sir is stay in USA. Earlier he was in Bangalore and was working with Honeywell. He left that and joined USA for PhD program. He has taught propulsion from USA for our GATE 2021 program. So you guys think of our resource capability. Even he went there, but he has passion about teaching, and the kind of terms we have, he has taken and he has done very well. Now, of course, Anup, you have put that Chandra your query. Yes, we teach fluid mechanics very well, and anyway, solid mechanics part is done by us everything, because in solid mechanics, gate XC we have engineering mechanics, solid mechanics, and vibration. All three are covered, and in fluid mechanics we teach till boundary layer everything. So that way, and in IGC, we have recommended our students to write GATE XC also. Today is GATE XC paper is scheduled. So that will be done. Okay. Some part you guys have to cover, but majority of the things we do. Okay. Anyway, mathematics aptitude we are teaching, complete solid mechanics we are covering, fluid mechanics also till boundary layer we cover very well. Only few topics of fluid machinery has to be covered by students watching the recording. Okay. Then we have mathematics faculty, Mr. Karthik sir is there, Mr. Prashant sir is there. Okay, so they take care of this aptitude and mathematics part. So this is about the team IGC. So have you inquired any other? Yeah, recording will be there in tool itself. In IGC online platform where we teach, there itself recording will be there. Okay, so not to worry. For 1 year program, sir, would you recommend book reading as a primary or video lectures or and self notes? See, book reading is like this. You have to refer books if you want really a good learning. Okay, as and when required, not as a whole. Okay, you just sit and read a book for a year. No, you have to attend classes regularly and then make self notes when you want preparing self notes, and if you want more clarity or suppose you are solving some questions, there you may require some references. Okay, so that should be done. It's like a combined effort. Okay, it's not like just reading books. Okay, but you guys must make your own short notes. Those should be of forever. Okay, till you write gate exam. Okay, one time notes effort should be there by everyone. See, these classes can be attended on any tool, either on laptop, mobile, or if you have tab. So there is no compatibility issue. Okay, and only thing, our IGC online platform will be browser based tool. Okay, no app. It's like WebEx has app. Okay, so you just need to open in Chrome or Mozilla. It will work. Initially, you may find if any issue, we will support for that. No, material will be provided in soft copy format only. Okay, no hard copy. See, I already, Subham, counseled you, right? When you called me. See, you can do masters in aerospace even through GATE EC. Okay. So it depends on the student, because in aerospace engineering there are two parts. One is a mechanical part and one is a avionics part. But in GATE aerospace there is no part from avionics section. Okay, we do study like navigation, control, these subjects. Right? Am I correct? Right, guys? In BTech, some of the courses are there from avionics, but in GATE exam there is nothing. So it up to you. Yeah, what is fifth semester VTU exam will finish on 6th March. Yeah, initially classes will be bit slow. Okay, will not take many classes. Okay, I understand, but we are like we set rules. We have announced classes will start from 21st long back. You guys will be remembering, right? Some of you are there in our WhatsApp group. So we neither prepone nor postpone, but we will maintain first 2 week. We will not take much classes. Okay, that's what. So classes will be in full flow by March first week around only. Okay, but if we delay now, then our promise of completing syllabus in November end will be delayed. Okay. Yeah, you can take print. If you want, take print on your own. No restriction, but no sharing with others. Okay. You cannot share any IGC work to anyone. Yeah, direct contact is there in WhatsApp group. No personal sharing. Okay. All faculty members are there in their respective group. But sometime you can contact, but don't disturb all the time, sharing personal messages. Okay. Fine. So about this is fine. This is about T. Now the syllabus coverage for our fab batch, it will be like this. We will start with no Google Classrooms and all. See, all the notes will be shared through Google Drive. Already I have shared the link of Google Drive. I will do approval. Okay, I will directly add your mail ID. We will have mail ID of you all. Okay, so we'll add. Fine. So no other platform, only WhatsApp. There we started Telegram also, because the number of students got more. But we found it WhatsApp is more used by people rather than Telegram. So we'll see which platform to use for discussion, online doubt discussion when in non-class hours. Okay, in non-class hours. So the syllabus coverage, engineering, mechanics, mathematics we are going to start. Then we will start structures basics, which is solid mechanics, which has highest weightage in GATE exam, and fluid mechanics, which is like aero basics. So in fluid we start with fluid property, kinematics, dynamics, okay, and fluid statics, and then boundary layer. So these are the 4-5 topics we cover in fluid mechanics. And then from July we start all core aerospace subjects like aerodynamics, gas dynamics, and by the time these big subjects, engineering, mathematics will get over, so we start aptitude. So this aptitude helps if you are fourth year students in your campus placements also, and it has already helped to many other also from our previous years students. Then we start in September aircraft stability and jet propulsion, and in October we teach aircraft performance and aircraft structures, and in November we start mechanical vibration, rocket propulsion, and space dynamics. So you can see this engineering mechanics is always connected with solid mechanics, and solid mechanics is connected with aircraft structures. This engineering mechanics and fluid mechanics again are bit connected in terms of the basics, and then fluid is connected with aero, and aero is connected with aircraft stability and performance part. Now if you take mm, here, one thing I have missed is thermodynamics part. Okay, here thermodynamics. So we also cover thermodynamics basics before moving to gas dynamics. Okay, so thermodynamics basics, then gas dynamics, and then we take up jet propulsion part. See, those one is a free group, Akash. Okay, free group is like ODF, Open Discussion Forum. This IGC AE 2022 is an internal group, and which is the only group required. Okay, free group is up to you guys. You be there or leave. Okay, for doubt discussion there are separate group. Okay, which I have not shared till now. Like we have separate group for aerodynamics propulsion, separate for aircraft structures, separate for engineering, mathematics, and aptitude, separate for flight mechanics. Okay, clear? So is that clear? So this is how we are going to complete the syllabus. Any concern in this part? Anyone? Quickly, guys. Any concern about syllabus coverage, how we are going to teach, from where we start? We start everything from scratch. Okay, let's move to next. Yeah, so these are the link for our sample work. So we have shared these links multiple times with you guys. You guys can go through for all these links, like for our sample material part, assignments part, sample online exam, sample, videos there on YouTube. We have many good videos on YouTube, like what is the opportunity or future of aero students, or the importance of GATE aerospace in aerospace engineering or aeronautical engineering students, or the subject related videos for previous year's paper solution videos, or topper talks on GATE preparation, or any other thing. There are many good videos, so you guys can watch and get motivated. In terms of the test schedule of the, see, test is like this. I suppose we are teaching engineering mechanics. So there are two part in engineering mechanics. One is statics and one is a dynamic. So we have exam for both. So like it is not hard and fast. You sit on that particular time and write. Okay, topic wise exams you can write once it is due anytime, anywhere. But it is always good you complete as early when exams are due. We will notify when exams are due. Is it okay, Glory? Yeah. Now come to our achievements. So these are our achievers from GATE 2020, and the best rank was rank 5. Mr. Sai Balaji, he was our one of the class students, and he did BTech from IST Trivandrum. Then the second rank was Nitin Sharma and Rajpreet. Okay. Nitin was our DLP students from IIT Bombay, and Rajpreet is the students from PAC Engineering College. This year's also we have students from PAC, IST Trivandrum, as I mentioned, IIEST Sipur, MIT Chennai, FGIT, from like many good colleges apart from all the private colleges like HIT, BMS, RV, JAN, you know, this Alliance, Bangalore-based colleges or outside Bangalore colleges. So these all our result. This guy was our fourth year students from RV College. Then this Akash and Uttam, they are from UP. No, it's already decided. We don't change our plan. The way we plan, we are going to teach. Okay. We are not going to teach you guys propulsion till we cover gas dynamics and thermo basics. Okay. We are not going to teach upfront stability or performance. You may feel I am not good or I am good in that subject. So at IGC, there are certain rules we follow. So these are the people from GATE 2020, and this is from GATE 2019, and he's a Manoj. He's a role model for us. Okay, in terms of the putting hard work and the using our support. Okay, then Mega Bharat was ranked 2, and any other. Yes, Swastik, you want to say something? Okay. Now this guy is Shashank, he's a Alliance student. Sai Ram Krishna is from Amrita College. This guy is from JNTU. Kavita is from FGIT Raebareli. All these, okay, are the students from different colleges. Now here we started our journey in 2018 when we got this guy Ram Gopal Soni ranked 27. Now he's a DRDO scientist, okay, based on the GATE score. And that particular year, this guy, V. Faninda Reddy, now he's in IIT Madras doing MS. So he was fourth year students and from very unknown college in Marathalli, where now we take our classes in Bangalore. So, with hard work in fourth year itself, you can get good result and you can get in IIT. Then this Himanshu came from SRM College, Chennai to Bangalore and he got this rank. Raj Gopal came from Bangalore, he got, and he's a Parthajit Majumdar. He was working in Bangalore in one company, in aerospace company itself. He got rank 3 and got in PSU, but he was mechanical student. Before that, we started briefly in 2017. Okay, kind of a crash course we provided. We started classes in September. We could finish in January, but result was 0. So we started our journey from 0 and it will go to best this year. Okay, so this is about us. Now, these are the few feedbacks from our previous students. Okay, we have shared with you guys. You can see the kind of work we provide. Okay, so this is Mega Bharadwaj. This feedback is way before she got All India rank 2, right? The result came in 2019 and she provided feedback on 10th December 2018. Before that, she took classes from somewhere else. 1 year she wasted. Now you see read this, because some of the institute claim her result. Okay, but you read, okay, because the kind of effort we put in mentoring students, it's not about you are just our class students or you are our DLP or you are test series students. Is it clear point, guys? Okay, so we do not claim result of any students till they are our students and they get support from us. Okay, even many people attended our online mock exam freely. We don't bother. Okay, whatever result they get, it is their preparation. Okay, we will bother result of our all students who have registered and paid. Okay, same thing will be there for you batch as well. Clear, guys? Okay. So these are the few more feedbacks you guys might have gone through. Yeah, now these are the doubt forum. So you can see, right? Someone has inquired. You can see here the doubt posted and the the support either by this IGC means our faculty, and GATE means student fraternity. Clear? So these are the further doubts. This is like you can see here, this is for basic fluid thermodynamics. So there also we support, provide a very good support. Now you can see this is post-gate guidance. Once you have a rank, how to use that rank in the best way, we provide the complete support for that as well. Is it clear? Yeah, fine. Then these are our online test series exams. So you can see here, for every topic, there is a listed exam. You take potential fluid flow. It is a small topic from aerodynamics. We have exam for or turbine. We have exam. Or if you take SOM, if you take beam, thin cell, column, we have exam. If you take thin walled structures or aircraft structure, we have exam for unsymmetrical bending, torsional, shear flow or flexural shear flow or shear center. Or if you take any topic like mathematics, linear algebra, differential calculus like this. So we are the only institute provide exam in such a a systematic manner. Everything like if you take your gas dynamics, we have exam for even Rayleigh and Fano flow. We have exam for CD nozzle. So that will make sure you are good in every topic. If you are good in every topic, then the whole syllabus will be easier. Okay, you of course will be good in the whole syllabus. So after all those topic wise exams which should be completed by November, and by every students we have subject exam. So for every subjects of GATE we have exam like aerodynamics, gas dynamics, engineering mathematics, propulsion like this. And we are now we are having around 20 subject wise exams here. Not all the exams are listed. Okay, and then we have 4 module exam and 10 full length exams. And you will find all 3 kind of questions, which is like NAT, MCQ, MSQs, all 3 kind of questions we put in our exam. And we are very fortunate, GATE 2021, as I told, was exactly our IGC mock exam. Now these are the contact details. We are Bangalore based institute, and we have classroom location in Marathali, and our office is situated in Panatur area where we stay. And these are our social media links. You guys can go through. We keep sharing technical, non-technical stuffs. So follow us there. Okay, those will be very helpful to many of you. So thank you guys. This was non-technical session. Now I will introduce quickly through our tools and all. So once I introduce to our tool, then you guys can, we'll start demo session. Yeah. Do you suggest any NPR? We suggest NPTEL videos also. Some of the good videos we suggest. In fact, we have made one document what all NPTEL videos are useful for GATE preparation. The weekend test exams content preview. No. None of our exams, not just weekend exam. The previous year's questions we solve only in classes itself. Means we complete all the questions in classes itself. Neither our assignments, okay. Mostly our assignments also not having any previous year's questions, or nor even our any exam. You will share that document, which, yeah, NPTEL, yes, NPTEL document again I'll share. The only thing which I found now, some of the links got changed, so I need to update. I have prepared that document, I'll share. Okay, yeah. And this previous year's questions is not to put in exam. Those only for self-practice, guys. For our exam, we have drafted ourselves, or we have taken from many good sources, good questions. Okay, that you guys will see. Okay, now come to this IGC tools. So first is our website. So website is very handy. You can see here all the informations are provided, which all should be there transparently. Now every time you have to visit our website to see the schedule, because the every week's schedule is shared on website. You can see the previous year's schedule for GATE 2021. And if you click on that, you will find all the details on particular day, what class is going, what is the time. Okay, see, you can see this GATE Aerospace Engineering for batch 3. So classes are taken by Space Dynamics on December 1st. On December 2, it was Engineering Mathematics class. December 3 was Space class. 4th, because it's a batch 3. So batch 3 is July batch. So they have class, you can see, on Friday also. So this is how the timetables. Okay. Yeah, someone has said. Oh, sorry. Yeah, screen was not visible. Yeah. Now is it visible? Yeah. I think now it is visible. Is it visible, guys? The weekend exam questions are of GATE standard. Rajat, yeah. Very much GATE standard. Okay. It will be, of course, the GATE standard of 2017 and 2021. Not like easy exam. Okay. We put some easy questions. Some questions will be tough. Now, is it visible, guys? Yeah, all right. So what I was telling, this is our website, iitiansgateclasses.com, and it is very handy. You can find lot many good things here, like previous year's question papers. We have authentic questions paper and authentic answer key also. Okay, and here you can all download. You can find the syllabus. You sometimes some of the materials will be uploaded in this Gate study material page where you can find our all sample work. Okay, I already shared. So guys, go through our sample work. So here you can see our sample assignments and sample material is shared, and in fact some materials are completely shared, like for thin wall structure or for space dynamics or any other subject. Okay, and then what is the highest use of our website every week is timetable, gate class schedule. So all the schedule will be shared on website. Okay, so you can see on this page, if you click, it will direct you to schedule. Okay, it seems to be a bit slow. Time, what is weekend exam? No, it's a flexible. Topic wise exams you can write anytime, anywhere. Okay, but you must write. Okay, I think it is a bit slow. Okay, yeah, so you can see it got open. Now if you take any schedule, you will find who is teaching, what is the timing. Clear? So this is about the schedule for classes. Now another tool is important is what online test series tool, where you guys have to write your exam. So I will open the exam. Okay, so you guys can see the exams, you can see the different exams. Okay, so if you can filter here, there will be several subjects. If you filter any subjects, you just filter like your okay, gas dynamics. So if you filter gas dynamics, all the gas dynamics related exams are there. Okay, you can attend, suppose Rayleigh and Fano flow. So if I attend these exams, suppose this topic is covered, so you can see this is MSQ questions, multiple choice, multiple answer. Okay, you can see this is the latest gate pattern questions. This is NAT, short answer. This is again NAT. This is NAT. Okay, so we have given, yeah, this is a MSQ. This is MSQ, short answer. So all these questions are there. You can see short answers, short answer. Yeah. So lot many numericals are given. This is a MSQ. Okay, so like this, different type of questions are given. Here, if you see, the virtual calculator is there, so you can, quickly you can use this like gate. It is very quick, okay? It is not slow, and it is a inbuilt. You can see here time is running, okay? Time will fly. So that is also important. So all these features of real gate are taken care. You guys can tell. I can give the answers. So what is Abhinav Chandra? What is your name? Abhiram Chandra. So this is like gate, right? You have written the gate exam. Yeah. So analysis, everything will be shown. Once you submit exam, in your gate result takes time, right? But this will not take time. Immediately it will tell. So I have attended two questions which were MSQ. So you can see incorrect, but still no negative marking, because for MSQs there is no negative marking. Here you can see what is your rank, who all has attended, you know, how much time you have taken. So like this. Now when we have subject exam, we initial few exams we categorize with the subject. So you can analyze which subjects you are poor, which subjects you are good here in category. But later on in your gate exam, there will be only two category. One is a aptitude and one is a core. So we will not categorize in the more subjects. So initial exams you have to analyze, okay, where you are weak and where you are strong. So here always the results is available, and as I told in mock test you will find all the mock test. Okay, if you take the A full length exam, you can see the 10 full length exams. Okay, clear? So this is now if you want subject exam, so just A module wise, A subject wise, you can all filter A. You can see all these subjects exams are there. In subject exams and topic wise exams, we don't keep 65 questions. Questions will be sometime 25, 20, 30, 40, like that. It varies. We give only a soft copy at the beginning. Okay, but for that you have to pay minimum amount. Okay, it will be one time sharing through Google Drive. Every time we will not share. Whatever we teach for online classes, there will be a separate drive where class notes will be kept if it is required. Okay, fine. So this is about online test series tool. And if you come to here, our sample work, you can go to study material. Okay, think it is taking bit of time. Let's go to next. I'll just elaborate on next part. Okay, yeah. So you can see now. No, Ranjit, we are giving two attempt, but we may restrict because few students. So this is our, coaching platform, IGC online coaching platform. So for that, you need always your credentials, and it is very private and safe tool. Okay. See, whatever we do, it is for you, not for your friends, because you have paid. Okay. So you have to give all credentials correctly. So you can see here, these are the classrooms. So when you open to this tool, you will see the classrooms and you can visit any classroom and you can find the recording of that classroom. Suppose it is SOM. So you will see the below all the classes conducted and all the recording will be there. Okay, so you can watch. So these are the number of students attended. Okay, so this is one of the recordings. Suppose open torsion of shaft. Okay, again it will ask credentials. Okay, and we also track IP. Okay, the one student should not frequently change here and there, like they should not do any kind of piracy, otherwise they will be restricted from classes. You cannot share your credentials with others. Okay, that is very much restricted. So in simple word, whatever is there, it is for you. Okay, not for others. What I need to explain? Yeah, I'll tell quickly, then we'll start the demo class. So you guys can see this is the how the recording will be there. Okay. Yeah. So this is about IGC platform. I'll close it. Yeah. You are asking something? What you are asking? In 1 week there will be 2 classes only. No, 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 no. There will be 4 to 5 class. Abhishek. That's what I was. IP part, like you cannot share credentials with a friend. Okay. You have to use for yourself. Okay. Because it's online. Okay. It should not be like just share with anyone. Otherwise, we will limit a lot. Okay. It should not be misused. Clear? That is separate team, IT team. Okay, we don't. I don't do personally. It is shared data from IT team. Okay, clear? Yeah, I think so. I think I have done from my part, and we'll move to technical part. Okay, before that, you guys can go through our sample materials and all. Okay, all the links are provided. So, Nitin sir, are you there? Yeah, Nitin
Yes,
sir
sir.
is there. So I'll share the presenter with you.
Sure.
Language, you know what we are using. It's a same language. There is no English funda at IGC. Okay. At IGC, it's a pure English. No English. No South Indian language, no North Indian language. Only one language, which is English. Our teachers are there from all different backgrounds. Some are from southern part of India, some are from northern part of India. I am from western part of India, some are from eastern part of India, but we have all common English language. Yeah, fine. Yeah, so please share.
Sure, sir. So, hello everyone. So Dinesh sir, I can start with the demo class, right?
Yeah, yes, right.
Okay. So hello everyone. So everyone, are you guys able to see my screen? Whatever I'm sharing, is it visible to all? All right, that's great. So hello again, guys. Good evening. So I am Nitin Somashekaran, and I will be taking subjects of aerodynamics and aircraft stability for you guys. And I've been part of IGC since 2017, 2018, around that time frame. So I started out while I was doing my master's. So I did my master's from Indian Institute of Science in Aerospace Engineering, and I passed out in 2019, and I'm presently working um, in an oil and gas company in Bangalore. So that is, a bit about my background, and I've been teaching here for, let's say, makes it around 3 years, by now. So yeah, so that's about my background. So today I'll be quickly taking you through a small topic within our
One thing I
academic.
will add, sir was AR 8 in GATE 2017. So which supposed to be one of the top paper like GATE 2021. Thank you, sir. Can continue.
Thanks. Yeah. So um, yeah. So coming back to our discussion, so today we'll be going through a small topic, just as an example to you guys, uh, to show you guys how we conduct the classes. So our classes are basically, we go in depth of things, we talk into detail, we do not just simply give you guys formulas. We really discuss the concepts, and from a gate point of view, that is what really makes sense as well. You need to know the concepts, otherwise it may not work out that well. So you would need to know the concepts really well, and that's what we teach. And we also do these previous year gate problems in class, so that you guys would get a sense of how our whatever we learned in that particular class can be applied from a gate point of view. And I know that there are folks who can understand the lectures quite well, but might face difficulties while applying that to a problem. So we would definitely, and solving the problem is what matters in the end from a gate point of view, right? So that is the main reason why we tend to solve, and almost pretty much all of the gate previous year problems will be solved in our class. Let's say if it is aerodynamics, and I'll be doing most of the aerodynamics previous year gate problems, and that'll give you guys a sense of what to expect from a gate point of view in that particular topic. And usually these gate exams are very much repetitive in the kind of questions, or at least in the type of questions. So once you do all these questions alone, you get a good confidence that, and you get at least a sense of how to attack these problems. And of course there will be some other difficult problems where you would have to think a little bit deeper. And again, that is why we take all the subjects in detail, so that you guys can do that. So with that, and please, guys, if you have any kind of questions while I am going through this demo lecture, please feel free to stop me. I'll be happy to explain in case there's anything that you guys want me to repeat. All right. So okay. So let's go ahead, and I'll go into the lecture. And today, in this demo class, I have decided to go over the. Just give me a minute, guys. Let me customize my window so that it's easier for me to do things. All right. Okay. Yeah. Yeah. So today in this demo lecture, I am going to talk a bit about the Bernoulli's equation, and I'll be going through the way I'll be following basically the method that we use in the class as well. That is, teach the concept and then try to attack the problems. And again, my name is Nitin Somashekaran. Um, yeah, so I know that some of you might be a bit rusty. Probably some of you are working as well, and so yeah, we will definitely go. We'll not be rushing through things, and that is not the final thing that we're looking at. We would definitely want every one of you to understand, and in case. And personally, from my end, I would give a lot of freedom to the students to ask as many questions as possible. And even if somebody doesn't understand whatever I've talked about, they are very much free to bring up any questions they might have, and then we can go over it over and over. And in case we do not find sufficient time in the class, you can contact me separately, and then we can discuss it. So the final point being, you guys need to understand. So do not worry about not being able to follow things. We'll definitely make sure that you guys understand. All right. So is there any question before I go to the lecture? Any questions, guys?
I think
All
sir
right.
can go ahead.
Sure, sir, sure. So, yep. All right. Okay. So let me erase everything in my window. Mm, uh, just give me a moment, guys. Mhm. All right. Okay. So one thing which I want to discuss is that just a brief background about what this Bernoulli's equation is, and I'm sure most of you have come across the term Bernoulli's equation, and you would have also seen that it is very much applied, and from a gate point of view as well, there are 1,000 questions you can expect, and every year it repeats, and from one point of view, you might think that it's a really simple equation, and then it's easy marks, and that's pretty much true. Any questions related to the Bernoulli's equation is just easy marks. You have this equation, you understand the question, you apply it. It's just pretty straightforward. So I wanted to use that, such a simple concept for this demo class, just to give an example to you guys. Um, so one thing is that the special case of the momentum equation, and you guys know that the momentum equation is a law, that is Newton's second law applied to a control volume. So Bernoulli's equation is pretty much a special case of it. So what I mean by special case is that when I put some assumptions on top of it, assumptions on top of my momentum equation, which is a law that every fluid flow must follow, I get my Bernoulli's equation. So momentum equation being a very complex guy which can be applied to any random situation or any situation in a fluid flow context. When I make some assumptions on top of it, I end up with my Bernoulli's equation, and we'll definitely go through all those process of making assumptions. And the assumptions involved in the Bernoulli's equation are, it's an assuming that your flow is inviscid. So and feel free to stop me, guys, if you guys have any question. I just want to repeat that. So one important feature is that we assume that the flow to be inviscid, not the fluid. Flow is inviscid, not the fluid. So which means that your fluid viscosity is a fluid property, right? Every fluid in the world will have some kind of viscosity. It's a physical property. But the flow is inviscid, definitely. It means that your flow is not really affected by this aspect of viscosity. That it at any region in your flow field, let's say you have a flow which is happening inside a pipe or a channel or whatever, whatnot it might be, we are not going to consider viscosity, we are not going to consider viscous effects. And when we consider viscous effects, you guys would know, I would have probably you guys can remember, there could be effects of boundary layer and things like that. So assigned to which the fluid is passing is non-viscous. So so the fluid, I'm not so here you need to keep in mind that the fluid is always will have some viscosity, but the assumption here is being that the flow is inviscid, meaning that let's say your flow is passing through any given space. Let's say the flow is flowing over a flat plate, or if the flow is moving inside a pipe or whatnot, we are going to assume that your viscosity or the inertia of the fluid is not going to play much of an effect there, that you are not going to have any boundary layer effects, you are not going to have any retardation of the fluid because of its interaction with the wall, nothing like that. And irrespective of what scenario, whether the flow might be moving through a pipe, it might be flowing over a flat plate, whatever it might be. So that is the assumption of being inviscid. So do not confuse it with the fluid being having viscosity given by mu to be zero. That's absolutely impossible. Your fluid viscosity cannot be zero. Only in certain cases you can assume that certain flow field can be inviscid, or certain flow fields can be assumed to be inviscid, and that is the only assumption that you can make. Never this is, you should not be following the fluid viscosity to be zero, guys. That's not right. Right? Any questions? All right. So um, Next, the assumption is that the flow is steady. So a steady flow means that with respect to time, none of your properties are going to change, right? So let's say if I have some fluid flow over a pipe and I look at one particular point in the pipe, let's say point P, which has some coordinates for that matter. And I'm going to look at this point. I'm going to look at the properties of the fluid at this particular point. The velocity of the fluid, the density, whatever it might be, and I'm going to track this property with respect to time. That with respect to time, whether these properties at this particular point are changing, and if my properties aren't changing with respect to time, and the properties, what I mean is nothing but the velocity, density, and temperature, pressure, whatever it might be, whatever properties you can think of. If these guys aren't changing with time, then I can call my fluid flow to be steady. So that is, or in a mathematical sense, you can assume that dou by dou t of any variable to be zero. All right. And my next assumption is being the flow to be incompressible. Incompressible meaning that my density is not a function of pressure. If time permits, please, I have a doubt. Yeah, sure, go ahead. What is your doubt? Got your point of fluid has some viscosity always, but what is inviscid here? The flow is inviscid. So so again, this is a very tricky concept. That is why I wanted to really stress on it um, in detail. So let me erase some of my writings away so I get some space. Uh, yep. Finding it difficult to. Uh, just a moment, guys. Uh, so, Dinesh, sir, sir, I am not able to clear the annotation, sir. Hello, hello. Is everybody able to hear me? Okay, okay. So let me see. I am not able to clear my annotations. Just give me a moment here, guys. Let me try to figure that out. Mm, okay, okay. Let me reshare my screen. I don't know because for some reason I'm not able to uh, not able to share. I'm not able to clear my writings on the screen. So let me reshare it. Okay. Yep. All right. Great. So let me start annotating, and if I see like I can erase it. Great. Uh, okay. So when I talked about the flow being inviscid over here, so what I mean is that, so I'm not saying that so so viscosity will have some effect on your flow field, right? As you guys would have heard of, your viscosity can in fact create these boundary layer and things like that. In fact, let's say you have a flow over a flat plate, it can pull down your velocity at the wall to be at close to the body to be zero, and then away from the wall to be of some higher value and things like that. So when I'm saying that the flow is inviscid or assuming the fluid to be inviscid, I'm saying is that I'm going to ignore these effects. I'm going to ignore the effects that my viscosity would bring in. That is, my fluid flow is not going to be retarded because of the presence of the wall, or there is not going to be any rotation in my flow field. That guys would have heard of your viscosity. Let's say you have a fluid element, and your fluid element is basically getting rotated because of the viscosity and things like that. So none of this is going to happen, or I'm assuming that none of this happens, in my flow field. So that is basically what the implicit assumption means, meaning that no effects of viscosity would be considered in my flow field. Viscosity cannot have any effect. Even if there is a wall, there's not going to be any boundary layer, there's not going to be any rotation, nothing like that. It's just going to be a plain and simple. All right? Is that clear? All right. So, and the next assumption being that what kind of approach do we use here? So we use an Eulerian kind of approach, not Lagrangian. So whenever we do any derivation from a fluid mechanics point of view, we rarely use Lagrangian approach, because that is very complicated, in which you have to track each and every particle, which is not that easy. And while the Eulerian approach gives you a wider picture, a bigger picture in a much easier sense. Um, so let me get my chat box out. So how come we go with Anna's equation here, sir? Please not laugh at me. I mean, it's okay. No questions are stupid, so it's fine. You can ask, how much, even if it's a very basic question. It's always entertainable. Why? How come we go with Anna's equation here? So um, so we so Navier-Stokes equation is basically, we do not go for any Navier-Stokes equation right here. If I go forward in my derivation, you can see that I'm not going to use any Navier-Stokes equation. Absolutely not. We are going to derive it from a much simpler formulation. In Navier-Stokes, the Bernoulli's equation can be derived from the Navier-Stokes equation, and that is the right way, or the most mathematically rigorous way. But here in this case, we are not going to do that. We are going to go for a much simpler approach, just for the sake of this demo class. I mean, we need to go with Euler, sir. So Eulerian approach doesn't always mean that it's an Navier-Stokes equation. So Eulerian approach can never be said to be, or let me rephrase this. Navier-Stokes equation cannot be is never equal to Eulerian approach. Eulerian is a broad spectrum of approaches that you can have in solving your problems, and Navier-Stokes equation is one byproduct of that approach. So you should never have that idea in mind that Eulerian equal to Navier-Stokes or vice versa, Navier-Stokes equal to Eulerian. They are very related, but it's just a part of it. So um, so so going for an Eulerian approach will offer a lot of advantages. Um, no. So that is the Euler equation that you're talking about, where viscosity is not considered. When you simplify your Navier-Stokes equation, you get the Euler equation when you assume that your viscosity is 0. But we are not going to do all those things in this derivation. Or this derivation which I'm going to show you is going to be much simpler. And the more rigorous way is just like you mentioned, that you go to the Navier-Stokes equation, make these assumptions, and then boil it down to the Euler equation, and from there go to the Bernoulli's equation. But that we would do that in a much more detailed session when we have your actual lectures, but not in this demo class at least. So in the demo class, the idea here is to explain a very simple concept in the most simplest terms. So we are not going to go to such complicated approaches, and we will adopt um, we'll adopt such methods when we'll be doing much more mathematically rigorous exercise when we go to the classes, actual classes. So yeah, great. And the next assumption being that the flow is in your density has nothing. So whenever maybe let me write that down. Why? Okay. So what I mean here is that my density rho, ah, density rho is not a function of pressure is what the incompressibility is basically meaning. So we need to put this assumption as well, and there are definitely versions of Bernoulli's equation you can see where you do not need this assumption, but in this lecture I'm going to assume this just so that it makes our life a lot easier when I'm in my explanation. All right, and so these are the three main assumptions that we are going to use in our lecture, and we will see how we can, in very simple terms, you can derive the Bernoulli's equation, and later on when you guys join us for the actual classes we will see much more rigorous method. And the method which I'm going to talk is very approximate. It is a very crude way of deriving Bernoulli's equation, not the right way. And the right way is deriving it from the Navier-Stokes equation, which is up to for a more detailed lecture, and which we are not going to look at right now. So whatever the derivation you see today, I wouldn't say it's the right way to derive it, but it is one way which gives you the answer, and the right way is something which calls for a much more detailed lecture. All right. Any questions before I move on? Great. So let me move ahead in my presentation. Um, all right. So for this derivation, what I'm going to do is that I'm going to take a streamline, in your flow field. And you guys know that, your streamline is basically a line that gives you the direction of your fluid flow. So you have your streamline over here, which right here, and it basically gives you the direction or the velocity direction or direction of your velocity vector in your flow field. And it's a very one of the basic concepts, right? A streamline. Mm. And what I'm going to do is that I'm going to take a control volume around it, and which is basically nothing but the Eulerian approach that I had mentioned, that you would assume a control volume while doing something in the Eulerian space, right? So I'm going to assume that there is a control volume around this guy, and it's a cylindrical control volume, as you can see in the figure. It's a kind of a cylindrical control volume that I'm showing over here, and we are going to apply our equations of motions on the cylindrical control volume, and finally we're going to derive your Bernoulli's equation. So keep in mind we have streamline, which gives you the direction of the flow, and on top of the streamline I'm going to assume that there is a cylindrical control volume. And control volume, you guys would be knowing, there are certain small volumes that you assign in your flow field, so that you can derive some of your laws. Any questions? All right. Okay, so next let me take you to what is happening to this control volume. We know that if you have a control volume, there are going to be forces acting on this control volume, and 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 we know that from your Newton's second law, we can always assume we can we once you sum up all your forces that is acting, so let's say sum of all the forces that is acting on any body is nothing but the rate of change of momentum. Let me write it in this way. All right. So our approach here is that to derive the Bernoulli's equation, we are going to take this control volume, which is cylindrical in nature. We are going to look at all the forces that are acting on top of the control volume. We are going to sum up all the forces that are acting on the control volume, and then we are going to take the rate of change of momentum of the fluid flow through the control volume. That is how much momentum is changing the rate of change of momentum within the control volume. So momentum of the fluid flow within or inside the control volume, how much is it going to change with time? And they both are going to be equal according to Newton's second law, right? So we have force that needs to be identified, and then we have your rate of change of momentum. All right. Any questions? Any questions? All right. So can you guys name one basic force that is definitely going to act on this control volume? very basic force, and you can probably see it from the figure in front of you as well. You have probably already identified maybe there are two forces that you can find from. Can you name what are these forces? Pressure force, absolutely. And is there any other force that you see on the screen in front of you? Weight, absolutely, absolutely, absolutely. Yeah. So we know that on the surface of your control volume, there's going to be some pressure force that is acting. So you have your cylindrical control volume right here, and on the surface of this guy, there's going to be pressure which is acting. So this is one surface of your this is one surface, which is, let me call it as the inlet surface, inlet, and let me call this guy as the outlet surface, O. So flow will come through the inlet and move through the outlet, and then there is, so this is a surface, inlet surface. There's an outlet surface, and then there is this curved surface, since we have a cylindrical control volume. All right, and on the inlet, let me assume that my pressure force which is acting is P, for that matter, some pressure force P. Hmm? And I'm going to assume that I have a very infinitesimal control volume, meaning that my control volume has a very small length, and the length is given by ds. All right, and you know that the pressure force will always act normal into a surface. So I have the inlet, and my pressure is going to act into this inlet surface. That is, it's going to be so when you have a surface in front of you, so let's say I have a surface like this, something like this, and your pressure force is just going to be into the surface, like straight through the plane of this paper. So that is where I mark my pressure to be in this direction. And similarly, I'm going to have some pressure on my outlet surface as well, right? And what I'm going to assume here is that my pressure, which is P, which acted on my inlet, and pressure which is acting on my outlet, they are absolutely, there is no reason to assume that they are equal, for that matter. So I'm going to assume that it is going to be some other pressure, not some other pressure. That pressure is not going to be equal to this P over here. It's going to be some P plus small change in the pressure that has happened as I moved from this end of the control volume to this end of the control volume. So from the inlet to the outlet, so the inlet, the pressure force was P, and the outlet is some that pressure plus some small change to that pressure. And since our control volume is really small, we can assume that the change that has happened to the pressure force is also really small. And especially that is the beauty of such the calculus methods, the infinitesimal, the method. So you have pressure force P at the inlet, and the pressure force at the outlet, again, which is acting into the surface. So its direction would be in this way, would be P plus and some small change to whatever the pressure was at the inlet, that is dP. And dP could be negative, positive, pressure can increase, decrease. We do not know. Just keeping it as dP. And this change is happening over a small length scale of ds. All right. Every Great. So please feel free to open up on any questions, guys. Even if it is a really basic question, I do not mind at all. All right. And now next thing is that we know the pressure P. Yeah, please go ahead. What is the doubt, Bhavesh? Yeah. And you can feel free to unmute your mic and speak up. Absolutely no problem. As we know that fluid will always flow from high pressure to low pressure. So, okay. Mhm. So the question here is that our P at the inlet might always be higher than what is P at the outlet. That's your question, right? Yeah. So that need not be the case always, for that matter. So if fluid is flowing from a high pressure to low pressure, that is, by nature. Let's say you keep fluid at high pressure, and then you keep then you have a low pressure region. The fluid is automatically trying to move to the low pressure region. But there can always be cases where a fluid is always going, the flow might always happen through adverse pressure gradient. Let's say you take a CD nozzle, right? So when it is passing through the divergent section, it is passing through an adverse gradient kind of or adverse pressure. So the pressure will keep increasing as we go on in this divergent section. So it doesn't mean that your fluid will so let's say you take a diverging nozzle for that matter. So it doesn't mean that when fluid is moving from one end to the other, its pressure is always going to decrease. There can be cases where the pressure is increasing as also, but the fluid, and in such cases, your fluid will be decelerated, right, as it is moving through such adverse pressure gradient kind of a scenario. So there can be cases where fluid is moving through an adverse pressure kind of a scenario where the region where the fluid is moving to has a higher pressure than from where it came from, essentially meaning that your fluid is moving against is not moving in a favorable pressure gradient kind of scenario. So it is not having a flow. Yep, exactly. It may not have a tendency to flow on its own. You have to push it through. Something is going to push it through. And as you all would have learned that your flow might get, you will have a deceleration when it goes through a diverging section. So that's something. So do not have this idea in mind, guys, where when I take flow at the inlet and the outlet can only be at a lower pressure than the inlet. That may not be the case, as you can know from this diverging kind of section. All right, you would have to push it. There can be cases where you're pushing it through. All right, is that clear? Any questions? Great. So, all right. So let me go ahead in my lecture. So you have your pressure force acting over here, and assuming that this area over here is A. So the force exerted by pressure is nothing but P times A. Or since it is an infinitesimal control volume, so I'm going to take it as dA, the area of the small section. So it's going to be P times dA. And similarly, the force which the pressure is going to enforce on the outlet is nothing but P plus dP times dA, and dA is because it's an infinitesimal control volume. And then you are going to have the weight um, of uh, of your fluid particle, or weight of the fluid is within your control volume. So let's say you have your control volume over here, and let me clear the annotations just to make the screen clear. So you have your control volume, assuming that it is filled with fluid. So what is the weight of the fluid inside the control volume? And it's nothing but rho times the volume of the control volume times acceleration due to gravity. And since it is a cylindrical control volume, your volume will be nothing but your dA times ds. So whatever this area is times your ds. Something very much similar to that of an area of a cylinder, right? Your cylinder has let's say you have a cylinder of radius r and height h and radius r. Just to make things clear, your base area of the circular section is nothing but pi r square, and times this height h gives you the volume of the cylinder. And that is the same concept over here. This has an area dA times the height of the cylinder ds, so you get dA ds, and let rho be the density of the fluid that is contained within this control volume, and rho g dA ds becomes the weight of the fluid, or the body force, as we call it inside the control volume. All right, so you have the force due to the weight of the fluid. And just to add on a detail over here, assuming that your weight will always act in the direction of gravity while your streamline is aligned at an angle theta with respect to this guy. So I'm going to take a few components over here. One is the vertical, the horizontal, and the component, the component of this weight along the direction of the streamline, and the component of the weight which is perpendicular to the direction of the streamline, and the guy which is in the direction of the streamline is or parallel to the direction of streamline is given by rho g dA ds cos theta, which is basically nothing but a simple resolution. So you have rho g dA ds, which is vertical. I take the component of this guy, which is nothing but cos of whatever this guy is. So resolving the weight in horizontal and vertical component terms, you get rho g dA ds cos theta parallel to the streamline, and perpendicular to the streamline is rho g dA ds sin theta. All right, just an added on detail. All right, guys, any questions on that? Is that clear? Great. So let me, and then just a quick detail over here. So let's say um, the inlet is over here, and this is a streamline of length ds, and which you can see. So your inlet will be over here, and then the outlet is over here, and this is the length ds, and this is the angle theta, which I just mentioned over here. And the height difference, the vertical height difference between the inlet and the outlet, let me take it as a small dz, infinitesimal height difference between the vertical height, for that matter, dz. So from the triangle you can understand that cos theta is nothing but dz by ds, and dz I can write it as ds cos theta. Just something which you guys need to keep in mind, and we'll be using it as a part of your derivation. This is just simple geometry, um, guys. From this, let's take a triangle like this. So height difference, vertical height difference, dz between in the inlet and the outlet. So this is the inlet, this is the outlet. So this is a vertical height difference, vertical in the sense with respect to the direction of gravity. And if this is ds and this is theta, so dz is definitely from the triangle. You can see that it's ds times cos theta. All right, is everything clear? Shall I move ahead, or is there some questions that you guys have which needs to be answered? Any questions? Are things clear? Am I going in a right pace so that you guys can understand? I know that some of you guys might have their concepts rusty. So am I going in the right pace, guys? Great. All right. So let me move ahead to my next slide. DZ and W are in the same direction. Yep. DZ and W are in the same direction. Yep. All right. So let me move to the next slide. So here is where the mathematical beauty happens. So again, so now we are going to sum up all these forces that I have identified, right? I have PDA. Oh, sorry. Let me go back. Let me see if I'm able to annotate. Oh, this is crazy. Sorry guys for this technical hiccup, and it's just crazy. Let's see. All right. Well, I think it looks like. Oh no, again. It's fine. Let me see. Oh, okay. Okay. So let me try to make this right, guys. For some reason, I'm not able to annotate all of a sudden. Okay, nope. All right, so we are back, guys. Sorry for that hiccup. Yeah. So now what we are going to do is that we are going to sum up all these forces. So assuming that the direction of the streamline, this direction is the positive direction, we have identified some forces, right? PDA at one end, and here P plus dP times dA in this area. And then you have your component of your weight, that is rho g dA ds cos theta, for that matter. So we are going to sum up all these forces. So what would be, so PDA, is it in the positive direction or the negative direction, guys, according to the convention that I just mentioned? Is it going to be the positive or the negative direction? PDA, the pressure force acting at the inlet. Positive. All right. Okay. And P plus dPdA, since it is against the direction of streamline, it's going to be in the negative. So here you can see PDA positive, Mine and this is nothing but negative of P plus dP times dA. So you have negative PdA, negative dPdA. So it's in the opposite direction, guys. And then your weight force, the component of your weight is also acting in the opposite direction to your streamline, right? When I resolve this guy. So that is also taken to be negative. So this is nothing but the sum of all forces, which I just mentioned. All right. And according to Newton's second law, it's nothing but the rate of change of momentum inside your controlled volume. So rate of change of momentum, if I may write it in this way, is nothing but rate of mass within the control volume times the velocity within the control volume times dt. And in Newton's second law, we do take the material derivative, right? It's the Newton's second law is uh, for uh, for a fluid particle or a system as well, and now we are applying it to the control volume. So we do this. And the mass within the control volume is nothing but rho times dA times ds, and the velocity v by dt. And then I'm going to take rho dA ds out, because that is going to be pretty much constant within my control volume, right? And that's what we assumed in the beginning as well. So rho dA ds I'm taking outside, and then what I have left is nothing but dv by dt. That is the total derivative. And total derivative, you guys know that can be resolved into a material, the unsteady term, the temporal term, and then the term which we call as the advection term or the convection term. If you guys are able to recollect from your old, let's say, from whatever you've learned earlier. So you have the mass, rho dA ds, rho times the volume, and the dv by dt right here. And dv by dt being the total derivative, I'm going to split it as dou v by dou t and v dv by ds. And and so usually you guys would have seen it to be dv by dx and things like that. So here our direction of motion is along the streamline, and whose direction is taken to be in the coordinate s. So just like you have x coordinate, y coordinate, or x and y showing the direction basically, or the way your fluid is moving. So here the coordinate symbol which I'm using to represent my streamline, or the direction of streamline, or the motion of the fluid, is s. So that is why we have dou v by dou s times v, and then dou v by dou t. So looking at, you have a term which represents how the velocity would change with respect to time, and then you have a term which we call as the the advection term or the convection term, which basically tells you how this particular velocity is changing from one end to the other, or from one point, let's say from one point in the control volume to the other point in the control volume, how this velocity is going to change, and how much of this property is being carried out, and which has a lot of intuitive physics into it, which I'm not getting into the detail right here. So my rate of change of momentum, or the right side of my Newton's equation or Newton's second law, is given by this. Oh, I'm sorry again. So right side of my Newton's equation is given by, let me see. Oh, this is crazy. So so the right side of my equation is this, and my left side of the equation is nothing but rate of summation of all the forces. All right. Any questions, anybody? Anywhere you guys are finding a difficulty in understanding, please feel free to come up. Anybody? Any question? All right. So shall I go ahead? Shall I move ahead with the lecture? All right. So now, um, so now, what I'm going to do is that these two guys are cancelled out essentially, which you guys can evidently see. And then I have a dp, dA, and then there is a dA term common everywhere, so I'm going to cancel that guy out as well. And then I'm left with this equation where I have minus dp minus rho g ds cos theta is equal to rho ds into whatever this term in the bracket is. And this is what we call as the Euler equation for study. Yes. Any question? I guess. All right. Yeah. So this is nothing but what they call as the Euler equation, and Euler equation is nothing but the Navier-Stokes equation, or more basic to that, the momentum equation when cast in an inviscid form, assuming that there is no viscous forces acting on your body, and I use that assumption on top of my momentum equation, and that's how I get the Euler equation. May you know how did you get the rho v dv in fifth line? Rho v dv. I'll come to that. I'll come to that. Let's not jump the gun here. I'll come to that. As we go on. Yeah. So this is the Euler equation. And then what I'm going to do is that I'm going to, and since we already assume that your flow is going to be steady, so we know that any property change with respect to time is going to be zero, just like I mentioned, dou by dou t of any variable is going to be zero. So I'm going to take this guy out and I have equation in this form, just a very small simplification. And then another simplification that I'm doing is, in the previous slide we saw that ds cos theta is nothing but dz, right? dz being the vertical height difference between the inlet and the outlet, and ds being the length of this guy. And this is something which we saw in the previous slide. So I'm just going to replace ds cos theta as dz. All right. And next, and coming to the question which we have. So next simplification that I'm going to do is that I'm going to take this guy and then look at this guy. So I have rho ds v dou v by dou s. And you guys would already know this from calculus, that dou v by dou s times ds can essentially be written as nothing but dv. That is, the rate of change of v with respect to ds times a small change in s is going to essentially tell you how much your v has changed. All right. So I'm combining dou v dou s times ds into dv, and which is very much understandable, right? That you have the rate of change of v with respect to this guy s, and then I know how much s is changing. So when I change s by a small amount, I get to see by how much small amount my v has changed, which essentially brings you back to dv. So that is how I am writing s ds dou v dou s as dv over here. Is that clear? Is that clear to everybody? Any confusion? So I may be wrong, but it's partial derivative. Yep, even if it might be partial derivative, it doesn't really matter. Even if you have a total, what does a partial derivative and a total derivative, or a ordinary derivative mean? A partial derivative can have its components. Partial derivative is always taken when a variable is dependent upon number of variables, right? So here, what I'm just saying here is, let's say with respect to single component is nothing but the ordinary derivative. So when I'm saying that, so even if you have a total derivative or a partial derivative over here, it doesn't really matter. So what we are doing is that I'm just taking how much my v is changing with respect to s. I know if my s changes by a factor of 1, my v will change by a factor of 4. And if s is changing by a factor, let's say my change in s is 2 units, so my total change in v will be 8 units. Something like that. Is that clear? So even if it is a partial derivative, it just shows you how much is going to change with respect to a particular thing. So if for a unit change in s, my change in v is 4. For a 2 units of change in s, my total change in v will be nothing but 8. Something like that, when you look at it in numbers. What is the physical significance of substantial derivative? So substantial derivative is something which I don't want to get into a lot of details over here, but substantial derivative, or what we call it as dou by dou t, is something which we use in a Lagrangian formulation. So let's say you were to track your particle. Let's say you have your fluid and you are keeping tab on this fluid from time one second to, let's say, time infinite seconds, and you're tracking whatever happens to this particular fluid particle. So the substantial derivative comes in such a scenario. But when I am so now I'm going for an Eulerian approach, right? So I need some equivalent of this substantial derivative in my Eulerian space. So that is how we have this beautiful relationship connecting my total derivative to such terms like the unsteady term and the advection term. So it's basically like substantial derivative is basically like a bridge between your Lagrangian formulation and Eulerian formulation. And I do not want to get too much of detail into that in this lecture, which basically we can talk about in much more detailed lectures if of and we definitely will go through such details as we go on in our lecture, let's say, in case you guys join in. All right. We're able to change dou v to dv multiplying with ds only because it changes with time is 0, right? Uh, Not only with respect to that, even if the change with respect to time was 0, I can still write my dou v by dou s times ds as dv, because I am only concerned about, so this guy is nothing but how my v is changing with s, and this is telling me how much the change in s is. So if I multiply both these together, I should get a change in dv, right? Irrespective of whether v being a function of time or any other thing in the world. All right, is that clear to everyone? Everybody with me? Any more questions? All right. So, okay. So since let me move ahead in my lecture. So we essentially boil it down to, oh my God, again. Yeah. So again, we boil it down to this particular formulation where um, just give me a minute, guys. This is very very okay. Got it. Yeah. Yeah. So um, so finally, we simplified this to this expression as time come, as my friend said. Where did the aspect of time come here, as my friend said? So we always have this. There is time derivative term, right, which we assume to be 0 in unsteady case. So yeah, that is from where that time came, and we definitely are assuming that there's no change of things with time, right? So all right. Okay. It's already 0 instead. Yep, it's already 0. But yeah, so that question was related to the question was basically like, since can we only write v dv dou v dou s as dv if this condition is true, if it is a steady flow, which is absolutely not. Otherwise, also you can write it. All right. So now, um, I'm just going to combine all these terms towards take all these guys to one side. So I have dp, I have rho g dz, and rho v dv is equal to 0. Okay, and then which is just a rearrangement of terms. And then I'm going to divide the entire equation by this density guy. dp by rho plus g dz plus v dv is equal to 0. So this is what they call as the Euler equation for steady flow. So we have assumed things to be steady, things are inviscid, all those conditions being satisfied. And now, to reach our Bernoulli's equation, what I'm going to do is that I'm just going to integrate both sides, LHS and RHS. So when I integrate LHS, I get integral over all individual terms, right? So I have integral over dp by rho, integral over g dz, integral over v dv is equal to some constant. And integral of 0 is some constant, right? So that is why we keep it as constant. All right. And integral of dp by rho. So integral of, and rho, since rho is not a function of pressure as we had assumed previously. So integral dp is nothing but p by rho plus dz is, and g is not a function, assuming that g is not a function of vertical height, which in reality g is a function of vertical height, but we are going to assume that it is not. So I get gz plus v dv. When I integrate, I get v square by 2, right? And this is all equal to some constant. So since rho is not a function of p, I take rho outside this integral expression, and rho is constant in this case, right? So integral dp gives you p, and g dz, g is not a function of dz, z, vertical height. So I take g out of this integral, and I integrate dz, which I get simply z, the coordinate, and v dv. So I'm just so use your usual integration, and then you get integral of this is nothing but like integral of x dx. So that's nothing but v square by 2, right? So p by rho. So in the end, we get our Bernoulli's equation, which is nothing but, let me open the next slide up. Yeah. So the expression which I just showed you guys, uh, yeah, p by rho plus gz plus v square is equal to constant, which is nothing but the final form of the Bernoulli's equation. And each term is represents some form of an energy, energy per unit mass. So there's nothing but the potential energy, sorry, pressure energy per unit mass. Gz is nothing but, that mgh, and in this case, since z is the coordinate along the vertical direction, mgz, which is nothing but the potential energy divided by mass. So gz is nothing but potential energy per unit mass, and half mv square is your kinetic energy, which you guys know, and if I per unit mass I take divided by m, so there's nothing but the kinetic energy per unit mass. So pressure energy per unit mass, potential energy per unit mass, kinetic energy per unit mass is some constant, for a flow field under these given assumptions, that it is steady, it is incompressible, it is inviscid. So this is basically our powerful and simple Bernoulli's equation. All right. Any questions, anybody? Any questions? All right. And few comments, and please feel free to bring up any if you guys are finding. And so keep in mind, one thing here is that this is not the right derivation. This is not the right way to derive Bernoulli's equation. It's just that it does the job for us. And the right derivation is much more rigorous, has a lot of mathematics involved, and you would derive it from our Navier-Stokes equation. And that is up for a detailed lecture that we always do with the class students. So this is just to give a context on how we teach. All right, and just to give you and another important aspect to keep in mind here is that though these guys represent some kind of energy per unit mass, this equation is purely derived from momentum equation and not an energy equation. So you should never think of the Bernoulli's equation being like an energy kind of an equation, though it represents some form of an energy, but it's not necessarily that it can only be derived from the energy equation. And as I mentioned, you can also derive the same from your steady your one first law of thermodynamics, that is your steady state energy equation for that matter. So that is one way of doing it. You could derive it from your Navier-Stokes equation, or you could derive it the way just I mentioned, which I see to be one of the most simplest method. And there are multiple ways to arrive at this, so in a sense. And keep in mind, another thing to keep in mind here is that for an irrotational flow field, that the Bernoulli's equation is applicable. The Bernoulli equation is applicable at any point in the flow field. But if the flow field is rotational, it is applicable only between points on a given streamline. So which means that, let's say you have a rotational flow field. Irrotational flow field in the sense is that the vorticity at every other point is 0. Your fluid particles are not rotating on their axis. So in such a flow field, I can apply, let's say you have some flow from left to right, and this is an irrotational flow field, because somebody told you, assume. So I take one point here, another point here, I can apply the Bernoulli's equation between these 2 points, meaning that I can take P1 by rho 1 plus, or let's say rho itself, plus GZ1, the height of this point, plus V1 square is nothing but P2 by rho plus GZ2 plus V2 square by 2. So I can apply Bernoulli's equation between point 1 and point 2, and this point 1 and 2 can be located anywhere in my flow field. It can be here and here, here and here, anywhere. Doesn't really matter. And this is only for a flow field where this condition is true. Your flow field is irrotational. That is, your velocity vector or your vorticity is zero at every point. But if it is a rotational flow field, your Bernoulli equation is still usable, but only at any 2 points in a streamline. Let's say you have streamlines of a flow field given by this. So I can apply between any 2 points in a streamline. So point 1 and point 2. I can use Bernoulli's equation between these 2 points. I can use, let's say I have points 3 and 4 here. I can use Bernoulli's equation between these 2 points. I cannot use Bernoulli's equation between point 1 and 3 if it is a rotational flow field. All right. So this is one important aspect that you guys need to keep in mind when you deal with Bernoulli's equation. All right. Are those details clear? Any questions, anybody? All right. So is Dinesh sir online?
Sir, I'm there.
Yes, sir. So do we have time, sir, or
You can take up one question. Okay, sir.
all right.
You can.
All right.
Yeah,
All right.
sure.
Okay.
But
Okay.
try to wind up quickly, 5
Sure,
minutes.
sir.
Then
Sure,
we'll
sure.
have a break. Yeah, sure.
Sure, sir. Sure. So let me move to a question, a previous year gate question to demonstrate the same. And this is a very simple question. And you guys would already know that the Bernoulli's equation can be applied to a pitot tube. A pitot tube is nothing. Pitot static probe is nothing but something which you typically use to measure the velocity of your flow field. That is, let's say you have a flow field here, and you immerse this pitot tube on this flow field, and you have ports on your pitot tube that measure the static pressure, P static, and you have ports in your flow field that measure the total pressure, P naught, and using the Bernoulli's equation. So you know that the Bernoulli's equation um, can be applied in such scenarios as well. So P naught will be nothing but static pressure plus half rho V square by 2. That is, if I take 2 points over here, so let's say I take a point inside this stagnation or the place where your flow field is going to be decelerated to zero velocity. So we know that the velocity here is going to be zero with some pressure, let's say P naught, which is nothing but your total pressure. And you have these static ports which measure the static pressure, which I call it as PS, and the velocity over here is nothing but the velocity with which your flow is coming in, V infinity. So I can definitely apply my Bernoulli's equation between these 2 points in the flow field, as long as my flow field is rotational. So I'm going to write, and assuming that these both points are not that separated largely with height, so my G Z term is pretty much close to zero, or GZ. The height difference is not that great, so I'm just going to ignore the height difference. So you guys would have already seen that I can write my P naught plus half rho V naught square. V naught is zero at this point, or the velocity is zero at this point, is nothing but the static pressure plus half rho V infinity square over here, half rho V infinity square. So that is the expression which connects your total pressure to your static pressure, and one of the most simplistic application of your Bernoulli's equation. So keeping this in mind, let me move to our problem. Yeah. Let me move to our problem. Let me quickly. Yeah. So here we have it's a previous year gate question, and we will be solving most of them, in our classes as well. So we have an aircraft which is cruising at 9 kilometer altitude. So you have an aircraft which is flying at an altitude of 9 kilometers above sea level. So it means that your density, your pressure, temperature, they are really different from what is there at the sea level. And let's say your free stream is coming at some, your aircraft is moving, and your flow is coming towards the aircraft at some velocity V infinity. The free stream static pressure and density at this altitude are 3.08 per 4 Pascal and density. So what they've given us in the question is that the static pressure of the flow here, static pressure of the air at this altitude is given by 3.08. I'm sorry. Me, yeah. So it's 3.08 into 10 power 4 is the static pressure of the air there, and the density of the air, which I call it as, we can represent, usually we represent any property of that of free stream, or the flow which is incoming to the air, which is undisturbed, that of the, we call it as free stream, and we give a notation of infinity to it. So P infinity, nothing mentioning, is nothing but the pressure of your free stream, which they have given it as 3.08 10 power 4, and your rho infinity, the density of the free stream, is given to be 4.467 kg per meter cube. And they've given a pitot tube mounted on the wing senses a pressure of 3.31 10 power 4. So you have so there's this aircraft, and then you have a pitot tube in front of it, and the pitot tube is measuring a pressure of 3.31 10 power 4. And we know that the pitot tube would measure nothing but the total pressure, the P naught, which I mentioned in the previous slide, right? The total pressure. That is the pressure that your sensor will detect if my flow field has been brought to rest, if my velocity is brought to 0. And the question here is, and that is 3.31 10 power 4 for that matter. So and now the question here is that, ignoring compressibility effects, what is the cruising speed? We need to find what is the velocity with which this aircraft is moving, and v infinity basically. So, and keep in mind this point over here, ignoring compressibility effects. So ignoring compressibility effects, meaning that when you have compressibility effects, your density of the flow will change with respect to, let's say, your free stream, your Mach number, your gas dynamics. Those things will definitely come in. And whenever you are asked to include compressibility effects, you cannot use the Bernoulli's equation in this form. You cannot really use it in this form, the form which I just showed you in the previous slide. There should be some tweaks to it. But since in this question, um, they are asking us to ignore compressibility, we can go ahead with this form of Bernoulli's equation, where I'm using P naught is equal to static pressure plus half rho v square. And what is the SI unit of H? H meaning the altitude, or H being the enthalpy. If H is the altitude, then it's meters. And if H is the enthalpy, I think, it's meters. SI unit is meters. And enthalpy is joule per kg Kelvin. Or no, joule, I think joule per kg Kelvin. Specific enthalpy. Joule per kg for that matter. So, so let me go ahead with the problem, and they have given me all the important details over here, and they're just asking me to find what is my P naught. So my velocity. So P naught is equal to P plus half P static, or P infinity plus half rho V infinity square. And infinity is a symbol that we usually represent for quantities relating to the free stream. And we know that P naught is around 3.31 10 power 4, and P infinity is nothing but 3.08 10 power 4, plus half rho infinity is around 0.46, if I remember right from the previous slide, and then V infinity square. So I just take this guy to the other side, and then V infinity is the only unknown in this expression, and then you would get your V infinity around 100 meters per second. So which is your option B, I suppose, in the previous slide. So this is like a very straightforward application, and this is a gate question, so keep that in mind. Very, very straightforward application of Bernoulli's equation, and just a small simple formula based upon the total pressure and the static pressure and finding the V infinity. And usually all questions pertaining to Bernoulli's equations are such straightforward questions, which you can easily score marks in. And one thing which I want to reiterate over told me that you can ignore the compressibility effects. If I were to consider the compressibility effects, I definitely can't use my Bernoulli's equation. I will have to use my gas dynamics equation. You guys might be aware of P naught by P is equal to 1 plus gamma minus 1 by 2 mac m infinity square whole power gamma by gamma minus 1 and things like that. So whenever they are asking you to consider the compressibility effects, you would have to go with the gas dynamics formulas. And if you go by gas dynamics formulas, your V infinity will be much different than what we calculated over here. And just because they told me I can ignore the compressibility effects, I went with the Bernoulli's equation and then did this quick calculation. So keep this in mind, guys. This is usually a place where people make a lot of mistake in. It's very easy to ignore this intrinsic detail, but make sure that you have this concept in mind: is that I can only apply Bernoulli's equation in this particular form for any problem that is P by rho plus GZ plus V square by 2 only if I'm ignoring the compressibility effects, or let's say my flow is incompressible, things like that. If compressibility effects are to be taken care of, then we need to deal in a different way. All right. So yeah, so that is one easy problem that I wanted to just share with you guys, and some interesting detail that can be very much overlooked. And yeah, so any questions here, guys, before I conclude? Any questions before I conclude? All right.
Yeah.
So this is pretty much going to be the format in which we conduct the class, at least from the aerodynamics point of view, that we talk to you about the derivation, we talk to you about the theory, we talk to you about any intrinsic detail, the actual details of the physics involved, and then we would do some problems related to it, mostly the previous year gate problems, and then any other questions that you guys might have. And yeah, and I hope I was able to give you guys a sense of what you can expect in our classes. Thank you, guys.
Yeah. So thank you, sir. Thank you. So guys, how is it? Guys can reply in chat. Okay. So that's good to hear, guys. To ask you, did you guys found any difference between offline and online coaching here? There is no difference in from my perspective, but you guys can write in quickly. Even if it is online, but learning can be very interactive, like offline. It depends on the faculty and the students, okay? So keep learning as interactive as possible, okay? So not to worry, though classes will be online, but it will be delivered very well. That's one thing I want to ensure you guys, okay? So here I will go briefly through aircraft structures, and aircraft structures is one of the tough topic in GATE aerospace engineering, and many of you may find it's a tough subject, right? Who all are agree? Is it tough subject? Aircraft structure is tough subject or easy? Yeah, because in aircraft structures, nothing is to mug up. You have to understand mathematics and physics of every concept. Lot many derivations will be there. You need few things like you need to be good in some free body diagram and some sign convention. We follow standard sign convention, and you need to be good in mathematics. If you are good in these three things, you can secure all marks in this SOM or structures. But yet I have to see the GATE 2021 paper. People have said structures was very tough. Okay. But in structures, there are three portions. One is a basic strength of material part, which is relatively easier. Then we have vibration part, which is also quite lengthier in our GATE aerospace engineering. And then we have thin walled structure. So thin walled structure is of course tough because lot much calculation has to be done in every questions, and questions will be quite lengthier. If you wish to work in aircraft industry, especially in aerostructure, where I have worked more than 8 years, you need to be very good in thin walled structure. In day to day, also you will use all the formula which we are going to derive in our gate classes, or we have been, learning in our engineering, like unsymmetrical bending, shear flow, torsional shear flow, and many other things. In fact, what all we discuss in strength of material or basic elasticity, everything is used in industry directly. Okay, or if you go for any interview, they will ask questions from what we discuss here. Okay, so let's start with a simple topic. Okay, let's start with a simple topic. Yeah, so stress strain relationship. So how many of you are aware about stress strain relationship, guys? All of you know Hooke's law. What is the Hooke's law, guys? What is the Hooke's law, guys? What is the Hooke's law? Yes, stress is proportional to strain, right? Like sigma is proportional to epsilon. But where it is applicable, guys? It is for 1D loading. Am I correct? Like from here what we find, sigma is equal to E times epsilon, right? So what is, guys? Sigma is equal to E times epsilon. Am I correct? So what is E here, guys? Yeah, we are talking stress-strain relationship for isotropic material. Because from this simple concept, they have asked many times questions. So what is E here, guys? Yes, Young's modulus. It's known as Young's modulus or modulus of elasticity. But as I said, this Hooke's law is applicable only for 1D loading. Now suppose you have two-dimensional loading. If you have two-dimensional loading, or if you have three-dimensional loading, then tell me, can we apply this Hooke's law? Can we, guys, apply Hooke's law? Or can I say my stress is directly proportional to strain? Anyone? Abhiram Chandra. No, you cannot, right? Because what happens, I will take one two-dimensional case. Suppose I have one plate and it is subjected to my stresses sigma x and sigma y, right? So I have two stress, sigma x and sigma y. So it is what, two-dimensional stress system. Clear? Now in this case, tell me, guys, what will be your strain? What will be your strain? I want, suppose, epsilon x. Will it be sigma x upon E? Because from Hooke's law, right? This is what should be your strain. But is it the case? Anyone? Yes or no? No. Or yes? No. It is not the case. What will be my strain? It will be sigma x by E minus nu times sigma y by E. So there is one additional terms. What is the additional term? Is due to my stress in y direction, there is strain in x direction. Due to what? Poisson effect. Due to what? Poisson effect. Is it clear? Is this point clear? Due to Poisson effect, I have one additional strain in x direction due to loading in y direction. Is this clear, you guys? Now tell me, guys, why it is negative? Tell me, guys, why it is negative? Why it is not positive? Can you understand physically? You guys see here, when I apply this sigma x, what will happen? It will get extended. Am I correct? So that is means strain is developed. Now what happens? This sigma y will oppose what? This extension, right? Means this contraction. Clear? So that means your strain is reduced when sigma y is present. That's why you can see here negative sign. Is it clear? Is this point is clear? So physically also we can understand when there is a plate, when there is a plate, when there is a plate and if it is subjected to stress in two direction, then your strain in one particular direction will be lesser if instead of this 2D, if it is subjected to 1D loading. Clear? Right? Because this guy is restricting motion in X direction. Okay? So this is what our physical understanding why this negative sign is present here. Okay? So this is how we derive stress-strain relationship for 2D stress system. So this is what your epsilon x. Now tell me guys, what is your epsilon y? My epsilon y will be sigma y by E minus nu times sigma x by E. Is it clear? Is it clear or not, guys? Quickly tell. See, guys, be interactive, okay? We are online, but still interaction must be there, okay? That's how we enjoy, okay? So good. Now, this I talk about two-dimensional stress system. Now, suppose my stress system or my loading is three-dimensional, right? If my loading is three-dimensional, that means I have sigma x, I have sigma y, and I have sigma z. How I can visualize if I take a cuboid? So suppose here you have sigma x, here you have sigma y, and on this face you have sigma z, right? Is it clear? The loading part, is it clear, guys? You have one stress in x direction, sigma x, I can write here. Then you have sigma z and you have sigma y. Right. So in this case, what will be your epsilon x? It will be sigma x by E. Then due to Poisson effect, you have minus nu sigma y by sigma E minus nu times sigma z by E. Is it clear? Is it clear or not, guys? Then similarly, I can write epsilon y, which is what? Sigma y by E minus nu times sigma x by E minus nu sigma z by E, and then I can write epsilon z, which will be what? Sigma z by E minus nu sigma x by E minus nu sigma y by E. Is it clear? So I have three strain term, right? You guys can see epsilon z, epsilon x, epsilon y. I can write these three equation in a matrix form. Is it clear? 1 by E can be taken out. So it is what? 1 minus nu, then minus nu 1, minus nu, minus nu, minus nu 1. Is it clear? Yeah. Nu or mu is what? Poisson's ratio. So this form is easy to remember. In matrix form, we can easily remember. And in this form itself, in GATE 2020, they asked a question. In GATE 2020. In GATE 2020, there is a question. We will solve that question. Okay, we'll solve that question. Clear? Okay. Now, guys, this here, what I have done, I have written my strain in terms of stresses. You can write by taking inverse of this matrix stress in terms of strain. So both the forms are very important in GATE exam to remember. In this, it is 1 by E. Here, my constant is E upon 1 plus nu into 1 minus 2 nu. Then it can be remembered because again, it's a symmetric matrix 1 minus nu, 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 1 minus nu, nu, like that. Okay, so these are the two equations for stress strain relationship and strain stress relationship. So based on this, we have two concepts. One is what? Plane stress problem, and one is plane strain problem. So we have seen the questions from these two concepts in previous year's paper, as well as directly question from this form. Okay, from this form. Okay, so we will take up those questions. Before that, if someone asks, why do we study, strength of material or aircraft structure? Anyone? Why do we study this subject in our aerospace engineering? Can anyone answer? What is the significance or importance of this subject? To me, it is, guys, very simple. Your aerodynamics sir will give me loads. Okay. Your aerodynamics sir will give me what? Surface loads. Okay. And body loads. Okay. Body loads are what? In broadly, we can categorize loads in two forms. One is body forces and one is surface forces. So body forces are what? Forces due to gravity. Okay. Or forces due to inertia. What is surface forces? You have force due to pressure or you have shear stresses, right? Those are surface forces. So what I have to do as an structural engineer, I need to analyze for applied loads, my structure is safe or not, or my design is satisfying my goal or not. Am I correct? Right? What your CFD team gives, CFD team will give us load, and as an structural engineer, what I will do for my every component of aircraft, I need to check something called margin. Have you guys heard about margin? What is the margin? There is something called margin of safety, factor of safety, right? So MS, factor of safety, FOS, or RF, reserve factor. Have you guys heard about these three? So my job is to find any of these three. All three means same. Only it's a different. The different company use the different name. Some use margin of safety, some use factor of safety, some use RF. Okay. So what is margin of safety? Relation between margin of safety and factor of safety? Anyone? Anyone have come across these terms? See, margin of safety is nothing but your FOS minus 1. Factor of safety minus 1 is what? Margin of safety. Yeah, you are correct, Jay Verma. Yeah. And FOS has to be always greater than 1, or your reserve factor should be always greater than 1. But your margin of safety has to be greater than 0. Okay, so this is what the difference. Okay, different company use different notification. So the whole idea to study this subject is to find always margins. Clear? Always check your structure is safe. How we find safe? We compare our maximum applied loads or maximum stresses. Okay, you guys might have heard about von Mises stress and principal stress. So we compare this quantity against what? Material allowable. Okay, and we find the margins. Clear? Okay. Now here we are discussing about stress-strain relationship or strain-stress relationship. So I told from this there are two conditions come across. One is a plane stress problem and one is a plane stress problem and another is plane strain problem. One more thing I want to tell here, guys, we have seen these relations are between, you know, your normal stresses to normal strain. But there is something called shear stresses and shear strain also, right? You guys know there are shear stresses and shear strain, guys. So what is the relation between shear stresses and shear strain? Anyone? What is your tau xy? What is the tau xy, guys? It is g into gamma xy. What is your tau yz? It is g into gamma yz. What is your tau zx? It will be g into gamma zx. Now what is the g, guys, here? What is the g? Yes, it's a bulk modulus, and we are going to derive also this relation, how we have got this relation between shear stresses and shear strain when we start our class. But between what is the g and relation between E? We know what is g. G is E upon 2 into 1 plus nu. Do you guys know this relation? Do you guys know this relation? G equal to E upon 2 into 1 plus nu. This again we are going to derive. Okay, this again we will derive when we start our real class. Okay, here my idea was just to give you essence and see how gate questions are. Now, based on this, I will solve one previous year's questions. Yeah, guys, look this question. This question is from GATE 2020. Guys, can you try this question now? Now tell me, guys, I have already given you guys in matrix form both normal strain to normal stress, and we can write also shear strain to shear stress. So tell me, guys, what is A here? What is the A, guys, here? Anyone? What is the A? No, afraid, just think. A is 1 by E, not E. So guys, we know what is the epsilon x. Let's write epsilon x is what? Sigma x by E minus nu times sigma y by E minus nu times sigma z by E. Correct? Is it correct? Yes or no? So what is your A? A is 1 by E. What is C, guys? It is minus nu by E. Now tell me, guys, what is the B? B is 1 by G. Am I correct? Because we know what is the gamma xy. What is the gamma xy, guys? It is tau xy by G. So what is the B? It is 1 by G. And what is the G we have written, guys? So it is 2 into 1 plus nu by E is what your B. Right? Am I correct? Yes or no, guys? Quickly tell yes or no. Okay. What I need to repeat? What is your name? C. C is, guys, here this equation is there, na? Minus C. C into sigma xx. So what is C? Now see, I will explain you what is the shear stress and what is normal, then you will see. The Poisson effect is not related with shear stress. because shear stress doesn't change volume, it only distort your structure. The change in volume is only caused by normal stresses. So Poisson effect doesn't come in shear. So J, now is it clear how my C is minus nu by E? Clear? Now my B is what? 2 into 1 plus nu by E. So I can write it like this. B by 2 is what? 1 by E plus nu by E. Now guys, what is the 1 by E? 1 by E is A. What is the nu by E? It is C. So what I got from here, B by 2 is equal to A plus C. So what is my C from here, guys? My C is A minus B by 2. So tell me what is the answer, guys? What is the answer? Everyone, please tell quickly what is the answer. So is it clear? Was it tough question? If you have clear understanding of the concepts, it's the easiest question. And it came for how many marks? 2 marks. Now tell me guys, was it tough to secure these 2 marks? Was it tough to secure 2 marks? And it's very interesting, right? What I need to explain B. Okay, Shreyas. B, right? What is gamma xy? What is the gamma xy? It is tau x by g. Now you see this matrix. What will be gamma yz? It will be B times tau yz. What is a gamma xy? B times tau xy. Then tell me what is the B? What is the B? Shrey? B is 1 by g, right? Is it clear now? Clear. Now we know what is the G. G is E upon 2 into 1 plus nu. So is it clear how to solve this question in a simplest way? You just need to understand what this matrix form, right? So these matrix form we already know it is, these are the relation between strain and stresses. Is it clear? Yes or no? Everyone? Okay, fine. So can I move to next concept? Right. So let's go back to stress strain relationship. And I told the application of stress strain relationship we use in plane stress problem. So can anyone tell me what is the plane stress problem? What is the plane stress problem? Anyone? No. Afraid 2D problem can be plane stress also, it can be plane strain also. Okay. We have to be very specific about plane stress problem. So plane stress problem means what? You guys, you can have 3 directions, right? X, Y and Z. If my stresses in Z directions are 0, what all stresses you can have in Z direction? One is sigma Z, then you can have tau Z, xz and you have tau yz. If all 3 are 0, then it is known as plane stress problem in what? XY plane. Clear? Because in this case you have only non-zero stresses in what? XY plane. So this is known as plane stress problem in XY plane. Is my voice is clear? Okay, so is this clear? What is the plane stress problem? Now in your aircraft is a thin walled structure. So your aircraft structures in thin walled, we always have plane stress problem. We will not have stresses along your thickness direction. Okay, we will neglect our stresses across along thickness direction. You will have your stresses in plane. Okay, because if you take in plane direction as a XY plane, then you will not have these three. Now guys, suppose my plane is Y, Z, my X. So in this case, suppose if your sigma X, tau XY and tau XZ are 0. Now tell me guys, this problem is plane stress problem in what plane? In what plane? Yes, it is plane stress problem in YZ plane. You are very correct. That's good. That's good. Now guys, tell me, for a plane stress problem in YZ plane, will you have epsilon Z 0 or non-zero? Anyone? 0 or non-zero? Yes. So what we are saying, for a plane stress problem, you can have a epsilon Z, which is what? Strain in Z direction non-zero. From where? We can see it from stress-strain relationship. My stress in X and Y direction produces strain in Z direction. Clear? So for a plane stress problem, if I consider my XY plane, if I consider my here actually, since plane was YZ, so I should have told epsilon X. Okay, because here perpendicular direction is X direction. But if you consider XY plane, if you consider XY plane, if you consider yeah, if you consider XY plane, so in XY plane, what is your epsilon Z? Your epsilon Z from stress strain relationship will be given by this equation, right? So though it's a plane stress problem or it's a 2D problem, but you have epsilon Z due to what? Poisson effect. So what it is? It is minus nu times nu by E sigma X plus sigma Y. Is it clear? Is this clear to everyone? Okay. Now, what is the application of plane stress problem? There are many application of plane stress problem. One is our thin walled structure, aircraft structure. Okay. Now you can see, beam problem, beam problem, your thin cell, right? Spherical cell, cylindrical cells, all these are what? Plane stress problem. Now, once you know the plane stress problem, next concept is what? Plane strain problem. So what is the plane strain problem, guys? Now tell me. What is the plane strain problem? Anyone? In plane strain problem, what will happen? You will not have strain in perpendicular plane. Suppose this is my xy plane, then my epsilon z, gamma yz, gamma xz will be what? 0. But what? Your sigma z may not be 0. Is it clear? Your strain in perpendicular direction will be 0, but stress may not be 0. How? Again, it is from stress-strain relationship. So what we see, non-zero stresses can be sigma x, sigma y, sigma z and tau xy, but non-zero strain will be how much? What? Only in plane, which is epsilon x, epsilon y and gamma xy. Now you see your stress-strain relationship. What is your epsilon x? It is 1 upon E sigma x minus nu sigma y and sigma z. I don't know about sigma z as of now. As of now, I don't know about sigma z. Now what will be epsilon y? It is again 1 upon E into sigma y minus nu times sigma x plus sigma z. But I don't know about what? I don't know about sigma z part. Is it clear? Now, how I know about sigma z? You guys know what is your epsilon z? It is 0. So 0 equal to 1 upon E sigma z minus this term. So from here we get sigma z equal to nu times sigma x plus sigma y. Now again, this is one of the GATE question and it came in GATE 2009, the year in which I appeared, GATE 2009. Okay, so can we see that question? Let's see that question, guys. Can you see this question? Read it and give me the answer. What is the answer, guys? See, in plane stress problem, stresses will be 0 in perpendicular direction. Okay. What is your doubt, Abhiram? Is it the same in plane stress problem? Stress in perpendicular may not be 0. I don't know. I am asking what you don't know. Plane stress problem itself says your stresses are in perpendicular direction 0. That is what the condition. Then why you are asking this, Sam, Abhiram, any? Is it clear? The definition of plane stress itself says your stresses in out of plane directions are 0. Is it clear? But you can have non-zero strain, which is what? Epsilon z, if your plane is xy plane. Is it clear, Abhiram? Yes, B is the answer. Okay, I will explain you guys this question. Now here plane strain problem, the satisfies condition. So guys, for plane strain condition we know sigma z is non-zero. A cannot be the answer. C is not the answer because we know sigma z was what? Nu times sigma x plus sigma y. D cannot be the answer, right? So what is the answer? B is the answer. Why B is the answer? Because we know gamma xz and gamma yz are 0, right? So that means what? Tau xz will be 0 and tau yz will be also 0, and we have already known sigma z is what? Nu times sigma x plus sigma y. Is it clear? This is for what? XY plane. Is it clear this question, guys, everyone? So this is how in GATE they ask questions. Was it tough again? I don't think it was a tough question. If you are clear with concepts, it's quite easy. Fine? Fine, guys? Okay, so that's good. Now, let's look one more question. Yeah, look here, these two easy question. Okay, first question you can leave. Tell me the answer for question number 2. Because we have now, for first questions, we haven't discussed anisotropic material. So what they told, for a plane strain problem in XY plane, in general, the non-zero stresses are what? We know sigma XX, sigma YY, sigma ZZ, and sigma XY. So which is the correct answer? I think I need to zoom it, right? So D should be the answer. Why C? Someone has told C is the answer. Okay, let me zoom. Okay, let me zoom this. Okay, let me zoom this. One moment. Yeah, tell me the answer, guys. So what is the non-zero stresses for plane strain problem in XY plane? Abhiram, do you think sigma x z is non-zero? How C is the answer? Guys, what is, okay, leave the answers, forget the answers. Tell me with your concept, what is non-zero stresses? Non-zero stresses for plane strain problem in XY plane are what? It is sigma XX, sigma YY, sigma ZZ, and what? Tau, tau XY, or what you can say, sigma XY. Clear? Is it clear? Yes or no? Clear? Right. So what is the answer? Abhiram, what is the answer? D is the answer. You can see here sigma XX, sigma YY, sigma XY, and sigma ZZ. Now here, instead of tau, they have written sigma. That also I will explain. Either you can write tau or sigma. That doesn't matter. What matters? This prefix I and J. If I equal to J, then it is normal stress. If I is not equal to J, then it is shear stress. So what is the answer? Finally, what is the answer, guys? What is the answer? The answer is D. What is the answer, guys? Answer is D. So that's it from my side for today's class. Okay. And I gave the brief essence how I teach. Okay. And what is the important in GATE. Okay. So thank you guys for this joining this technical session. and we can have briefly any other concern if you guys can discuss. Any concern about our classes, why it is only online? See, I will tell you the advantage of online class. The major advantage of online class is first, always recording is available. Second, the advantage, you can attend online classes from anywhere. Only requirement, you should have good internet. Third requirement, if you are Bangalorean, it will save a lot of time. You know, traveling was hardest part in Bangalore. Okay, uh, at least 1 year back. Now after this corona, traffic got down, but it got started again back. Okay, right? And we are not making our classes very fancy. We have kept our classes very simple. Are you guys agree with this? Our classes are very simple. We just like to teach as like we teach in offline. Is it right or wrong? No fancy things, no fantasy involved in our classes. Okay, we'll keep things very simple and interactive. Okay, another advantage of online classes, flexible classes. When classes are offline, we used to teach whole Sunday for 8 hours continuously. Many people will get bored. Now here, classes will be sweet and short, 2.5 hours maximum. Okay, the break will be given and new subjects will come. So interest will be intact. So this is another advantage. And you guys can tell any things apart from that, if you guys have lagged today. Yeah, one concern was writing for Nitin sir's classes, because in IGC tool it is quite easier. For me it was easier because I use iPad. So iPad is fantastic in writing. Okay. Sir also
Sir,
has writing pad, but the concern was tool. Yeah, tell me.
can you show one of those clips of the IGC of any with respect to the tools which you were mentioning, sir?
Yeah, clip I have shown na initially.
So
Clip
no, sir,
means
the only the writing part.
no, writing part now, see, I am in Cisco, okay. So if you want to see writing part, okay, let me share and see, okay. Let's do. But for that, I have to write with mouse. It will be bit tough because I need to connect that tool with my, okay. But again, I will not able to share through iPad that. But here I will show you, okay. Let me see if I can show you that part. But see, guys, tool should not be the big concern. Okay. The main thing, the quality is like most important for us. And when we started these classes were started, writing with mouse. So it was a big challenge. Okay. When nothing was there, lockdown was there, no shops were open. So I used to write, with mouse. Just was the only reason, student should not get hampered their studies. So that was the situation. Let's now we have everything. So come to that IGC tool. I'll share. Okay. So let me start a class. Okay. So this is the IGC platform. So here you can see on the here right, all the participants will be there. This is the public chat. Okay, here you can write like you were doing. Now this is the tool. Here we have all option to write. Since I am writing through mouse, so it is bit tough, but when I use pens or digital pad, it is quite fast. Okay.
Sir, do all the faculty use the pen, sir?
Yeah, all the faculties have digital pad or iPad. Nobody teaches through mouse. Okay, we have done this when nothing was available. Right? April month when lockdown was there. Even Kirana shop were used to find, it was tough thing. So we have gone through all the experience. Okay.
So one more question, sir.
Yeah.
Sir, like, do you take revision classes, sir? Like after
Yeah.
every subject is done, if you revise the subject at least for 2 or 3 classes, like it'll be a
No, it
pretty.
is done always in November, December month. Okay. We have dedicated problem practice classes. Even you can see this year we had some classes in January. Okay. But those will be not for revision. It will be for doubt support. Okay. Because doubts are more important. So revision you can go through. Na recording we are availing. You can
Okay.
do, go do, self.
My
But
last
doubt,
question, sir.
yeah.
Sir, like if required, can like people who are staying in Bangalore, can we like meet the faculty in person?
Yeah, of course, those things were there, but now we want to completely avoid offline classes for aerospace engineering branch. But still, we will be open for other branches. So sometime you guys can meet. Okay, but you need to travel wherever you stay. Okay, we are in Marathali. So this is how, see, it's very good tool. All the recording will be below your class. You can see. Okay. Once you attend class, we record, it will come like class 1, 2, 3, you can see in this order. Okay, and if you want to see the recording again, I can show you. It is a very, clear recording. Much better recording than any other tool. Okay, HD recording, you will get it. Yeah. Let's go if any interaction. Yeah. Okay. So is it clear, guys? Now what I will do, I will show you Nitin sir's recording itself. Okay. So if I go to our recording part, let me go to server recording or server room. Let me check. Yeah. So Nitin sir has taken subjects like, coming down. Yeah, aircraft stability, Hemraj sir, Navneet sir, Karthik sir, Utpal. Okay. So Nitin sir, where is Nitin sir? Is okay, Ram Shankar Utpal sir, Karthik sir, Navneet sir, Deepak sir, Raghuram Sambhu sir, Jassa sir. Yeah, Nitin sir. Okay. No, he has not taken flute class. Then why flute class is there for him? Okay, let me check by searching this way. Okay. Okay, just give me one moment. I will show his recording also. Okay, machine design. Yeah, Nitin sir. Yeah, aerodynamics by Nitin sir. So his recordings are there. Okay, let's open any random recording.
So, one doubt, sir.
Okay. See, the IGC tool is much more potential tool. Okay. Clear? Okay. So, okay, fine. So, any other doubt? Yeah, guys. Now, any other concern? Any other doubt about our course or anything? In chat box, you can write. If you guys want, I can share one more thing. How many batches are there? Usually we take 3 times admission, Feb, May and July. So basically batch 1 and batch 2 will be mostly together and batch 3 like this. Yeah. But May is not sure this year. So you'll have Feb and July. Okay. Any other concern? Now if you want to see, I can show this also. Like one more thing. Apart from this, I would like to show you guys this IGC drives, okay, where you find everything, every materials and all are there. So I'll just show you guys that as well. Yeah. Okay. So let me open that. Yeah. Yeah. So yes, guys. So I'll just share the last thing, then we will wind up. So you guys can see here. Yeah, so here you can see we have the dedicated folder which has study material assignments. If I open this folder, you'll find study material for all the subjects. If you go aerodynamics, you'll find the aerodynamics materials for aerodynamics, for compressible fluid flow, for fluid mechanics. If you go to structures, you'll find all the materials related to structures. You can see SOM, thin walled, vibration, the previous old material. These are important miscellaneous things. So like this, we have organized. If you go to aero propulsion, you will find the material for aero propulsion. Now it is well ready in the proper book format. Okay, this is how the new materials will be. Okay. We have already worked on some of the subjects and we will be completing this year all the subjects in this format. Clear? So this part Now come to this assignments part. Let me open the assignments part. You can see there are assignments for every subject. You can see for all subjects assignments are in place. If you open any subjects, let's open flight mechanics, you'll have the assignments for stability, you have assignments for performance. Okay, you can see here the assignments are there, respective solution is also there. So this is how we support, but we don't believe in hard copy things. Okay, everything is in soft copy format. And again, you cannot share it to anyone. All the things have to be kept with you guys. Okay, it's all very simple. Otherwise, you may lose all supports. Fine. So thank you for this, and I will take